Welcome to Milky Narratives. Tonight, set aside the noise of the day, breathe deeply, and let your thoughts drift gently among the stars. Together, we'll explore the quiet mysteries that lie beyond the edge of the known universe. 1. The night sky that changed humanity. Forever look up, and imagine that every human who has ever lived has shared this exact moment with you. The same stars that shimmer above your head tonight once watched over forgotten kingdoms, wandering hunters, ancient sailors, curious philosophers, and children who wondered whether anyone or anything might be looking back. Yet while the stars themselves have remained almost unchanged across thousands of years, the universe inside the human mind has transformed again and again. What if the greatest discovery in history was never hidden among the stars at all? 1. But inside the people who dared to question them? Every civilization believed the night sky was telling a different story. Some saw divine gods writing messages across the heavens. Others believed invisible spirits carried the sun through endless darkness. Entire empires rose, believing that the constellations controlled the fate of kings, the timing of harvests, and even the destiny of humanity itself. But what happens when one generation decides that the stories they have inherited might be wrong? Tonight, we begin a journey across thousands of years, not to watch the universe change, but to witness how human curiosity slowly rewrote reality itself. Along the way, we'll discover that every answer uncovered an even deeper mystery, and that perhaps the greatest revolution in history happened not on Earth, but inside the imagination of those who looked upward. Because sometimes, changing the way we see the stars changes everything we believe about ourselves. Long before telescopes, satellites, or space probes, humanity possessed only two extraordinary tools: patient observation and endless curiosity. When darkness settled over the first human communities, the night sky became far more than a beautiful display. It was a calendar, a compass, a storyteller, and perhaps the earliest classroom ever known. Imagine standing on an open plain tens of thousands of years ago. There are no city lights, no glowing screens, no electric lamps softening the darkness. Above you stretches an ocean of stars so bright that the Milky Way casts a faint shadow upon the ground. In such a world, ignoring the heavens would have been nearly impossible. Our ancestors quickly noticed that the stars followed patterns. Certain constellations appeared during particular seasons. Bright planets wandered differently from the fixed stars. The moon continuously changed its shape before beginning the cycle again. Slowly, these repeating rhythms became woven into everyday survival. Knowing when particular stars appeared could signal the arrival of winter. The first appearance of another constellation might indicate the perfect time to plant crops. Along coastlines, sailors learned to navigate by celestial landmarks long before maps existed. Without realizing it, humanity had begun practicing astronomy thousands of years before the word itself was ever invented. Yet observation alone could never satisfy the human mind. People wanted explanations. Why did the sun disappear each evening? Who moved the moon across the sky? Why did eclipses suddenly darken the heavens? What caused stars to fall? Without scientific instruments, imagination became the bridge between mystery and understanding. Every culture painted its own universe. The ancient Egyptians imagined the sky goddess Nut arching gracefully over the earth, swallowing the sun every evening before giving birth to it again each dawn. Across ancient Greece, heroic figures became immortalized among the constellations. Orion hunted forever. Perseus rescued Andromeda for eternity. The heavens transformed into an enormous mythological map where stories could never be forgotten. In China, astronomers carefully recorded unusual celestial events for thousands of years, believing that changes in the heavens reflected changes within the empire itself. Comets, eclipses, and strange stars were interpreted as cosmic messages carrying warnings for emperors. Meanwhile, indigenous cultures across Australia preserved astonishingly detailed oral traditions connecting stars with seasonal cycles, animal migrations, and navigation across immense landscapes. Many of these traditions survived for countless generations, demonstrating remarkable observational accuracy. Although these civilizations rarely agreed on why the stars existed, they shared something even more important. They all believed the sky mattered. This common belief united people separated by oceans, languages, and thousands of years. It also planted the first seeds of scientific thinking. Because before anyone can solve a mystery, they must first decide that the mystery deserves attention. Night after night, generation after generation, people continued watching. They noticed tiny irregularities. Some stars wandered. Some planets occasionally moved backward against the background stars, a puzzling motion now known as retrograde movement. Certain eclipses seemed predictable. The moon's cycle repeated with astonishing precision. These observations slowly accumulated like drops of water, filling an enormous reservoir of knowledge. No single observer could witness enough to understand everything, but civilizations could. Knowledge became something larger than any individual lifetime. Parents taught children. Teachers instructed students. Priests recorded observations. Scholars copied manuscripts. Each generation inherited questions that the previous one could not answer. And perhaps that is humanity's greatest superpower. Unlike any other known species, we accumulate curiosity across centuries. Each unanswered question becomes the starting point for someone else. Over time, the heavens transformed from a realm of divine mystery into a puzzle waiting patiently to be solved. The transition was gradual, almost invisible, yet it would eventually reshape philosophy, religion, navigation, mathematics, engineering, and ultimately, every scientific discipline that followed. Looking back today, it may seem inevitable that humanity would eventually understand the universe. But history tells a different story. Every major breakthrough required someone brave enough to doubt what nearly everyone else believed. Every revolution began with a simple observation. Every discovery started with someone quietly asking, "What if we've been looking at this the wrong way?" That question, small enough to whisper beneath a sky full of stars, would eventually change humanity forever. And our journey is only just beginning. 2. The first questions ever asked. Long before telescopes, before mathematics, before written history, someone looked upward and quietly wondered a question that still echoes through science today. No one remembers that person's name. No monument honors the first human who paused beneath the night sky and asked, "What are those lights?" Yet, in many ways, that forgotten moment may have been the true beginning of civilization. Not when humanity learned to build, not when we learned to farm, but when we learned to wonder. Because every discovery that followed, from navigation across oceans to rockets crossing the solar system, began with a question so simple that even a child can ask it. Why? Tonight, we journey back thousands of years to a world without books, without observatories, and without answers, where curiosity became humanity's greatest invention. Imagine standing on an open plain nearly 50,000 years ago. No cities illuminate the horizon. No airplanes leave glowing trails overhead. No satellites silently circle the Earth. The darkness is almost complete. As the last light of sunset fades, the universe slowly reveals itself. One star appears, then another. Soon, thousands emerge. The Milky Way stretches from horizon to horizon, like a luminous river flowing across eternity. Modern people rarely experience this sight. Artificial lights have hidden much of the cosmos from our eyes. But for our ancestors, this breathtaking display appeared every clear night. It was impossible to ignore. The stars became their oldest companions. Children grew up beneath them. Hunters tracked seasons through them. Families gathered around fires while countless silent lights watched from above. Eventually, someone noticed something extraordinary. Most stars stayed fixed in their positions. Night after night, year after year, generation after generation. The patterns remained almost unchanged. The same hunter, the same great bird, the same winding serpent imagined among distant lights. But a few mysterious objects refused to obey. They wandered, slowly, patiently, sometimes forward, sometimes backward. Unlike every other star, these strange travelers would later become known as planets. The Greek word planets simply means wanderers. Long before astronomers understood what planets truly were, ordinary people had already recognized that these lights behaved differently. Observation came before explanation. Curiosity came before knowledge. And perhaps that is still true today. As humans continued watching the heavens, more questions emerged. Why does the moon change its shape? Why does it sometimes disappear entirely? Why does the sun rise from one direction and set in another? Why do some stars only appear during certain times of the year? Why does winter always return? No one possessed instruments capable of measuring these mysteries. There were no equations, no laboratories, no scientific journals, only careful eyes, patient minds, and generations willing to remember. Knowledge passed through stories long before it was written. Grandparents pointed toward familiar constellations. Parents taught children when certain stars signaled the coming rains. Entire communities depended on these observations. The sky was more than beautiful. It was practical. It told people when to plant crops, when rivers would flood, when animals would migrate, when dangerous winters approached. The heavens became the world's first calendar. Not because anyone invented it, because nature offered it freely to anyone willing to pay attention. Across different continents, cultures separated by thousands of kilometers reached surprisingly similar conclusions. The sky contained order. It followed patterns, and patterns could be trusted. That realization changed everything. For perhaps the first time, humans recognized that the universe was not entirely chaotic. Some things happened for reasons, even if those reasons remained hidden. This belief encouraged something remarkable: prediction. If the stars always returned to the same positions, then tomorrow could be anticipated. If tomorrow could be anticipated, perhaps other mysteries also followed hidden rules. This simple shift in thinking planted one of humanity's deepest intellectual roots. The universe became something to understand rather than merely survive. Curiosity expanded beyond survival itself. Questions multiplied. Where does the sun go at night? What lies beyond the stars? Could someone live up there? Are the lights holes in the sky? Or are they enormous fires? Every culture developed different answers. Some imagined celestial gods steering glowing chariots. Others envisioned giant cosmic animals carrying the heavens across the world. Some believed ancestors lived among the stars, watching future generations. Although these explanations differed dramatically, they shared something profound. They acknowledged that the universe deserved explanation. That alone was revolutionary, because asking questions transforms fear into investigation. When lightning becomes something to understand rather than merely fear, science quietly begins. The same happened with the stars. Each myth represented an early attempt to organize overwhelming mystery into understandable stories. They were not foolish ideas. They were humanity's first hypotheses, incomplete, sometimes incorrect, but incredibly courageous. Imagine trying to explain eclipses without knowing the Earth is a planet. Imagine predicting seasons without understanding orbital motion. Imagine describing the Milky Way without knowing it contains hundreds of billions of stars. Given the limited information available, our ancestors accomplished something astonishing. They built intellectual bridges between observation and imagination. Eventually, observation became more precise. ancient sky watchers noticed repeating cycles. The moon completed its phases with remarkable regularity. The sun returned to the same position every year. Certain stars rose just before dawn at predictable times. Patterns accumulated. Memory became tradition. Tradition became knowledge. Knowledge slowly evolved into astronomy. Not overnight, not through a single genius, but through countless anonymous observers separated across centuries. Most of their names have disappeared forever. Yet, their legacy surrounds us every time we look upward. Even today, scientists continue asking questions that resemble those first ancient wonders. What is dark matter? Why does the universe exist? Are we alone? What happened before the Big Bang? Our instruments have changed dramatically. Radio telescopes span deserts. Spacecraft explore distant planets. Artificial intelligence analyzes cosmic signals. But the questions themselves remain deeply human. Every generation inherits mysteries from the previous one, then leaves new mysteries behind. Perhaps that endless chain of curiosity defines our species more than anything else. Not intelligence alone, not language, not technology, but the refusal to stop asking. The child pointing toward the moon, the philosopher contemplating infinity, the astronomer studying galaxies billions of light years away. All belong to the same timeless tradition, a tradition that began with someone whose name history forgot, someone who simply looked upward and wondered. 3. Mapping the infinite. Every map ever drawn has had an edge. Even the oldest maps carved into stone eventually reached a place where their makers simply stopped drawing. Beyond that point lay unknown lands, mysterious oceans, or imagined monsters. For thousands of years, humanity believed every journey would eventually arrive at some kind of boundary. A mountain too high to cross, a sea too dangerous to sail, a desert too vast to survive. Every frontier suggested that somewhere, somehow, the world would end. But as our understanding of the universe slowly expanded, a strange realization began to emerge. The greatest landscape of all might be the only one without an edge. How do you create a map of something that could stretch forever? This question transformed astronomy from simple observation into one of humanity's most ambitious adventures. The earliest sky watchers had already identified familiar constellations. They gave names to bright stars. They tracked the wandering planets. Yet these celestial maps were very different from the maps we know today. They were not designed to show distance. They were designed to preserve memory. A constellation was like a story written in light. It helped travelers navigate across empty deserts. It helped sailors cross dark oceans. It helped farmers recognize the changing seasons. Each pattern carried knowledge from one generation to the next. But eventually, people wanted something more. They wanted precision. If the heavens followed hidden rules, perhaps those rules could be measured. Perhaps the sky itself could be charted. Ancient astronomers began recording the positions of stars with astonishing patience, night after night, year after year, sometimes across entire lifetimes. Without cameras, without computers, without telescopes, only careful observation and remarkable discipline. Every tiny movement mattered. Every unusual appearance was carefully remembered. At first, these measurements seemed almost impossible. The stars appeared fixed, yet over decades, subtle differences became visible. Some stars rose a little earlier. Others seemed to drift ever so slightly across the heavens. The sky was not frozen. It was alive with motion too slow for a single lifetime to fully appreciate. This required a different way of thinking. Astronomy became a science measured not only in space, but also in time. To truly understand the heavens, one had to think across generations. One observer would begin the work. Their children might continue it. Their grandchildren might finally understand what the first observer had noticed decades earlier. Few sciences demand such extraordinary patience. As civilizations grew more advanced, so did their maps. The heavens were divided into coordinates. Stars received catalog numbers. Their brightness could be compared. Their positions could be predicted. For the first time, the night sky became something that could be organized with remarkable accuracy. Yet every answer uncovered another mystery. If the stars occupied different positions, how far away were they? Which ones were nearby? Which ones were unimaginably distant? Looking upward provided no obvious clues. A candle nearby can appear brighter than a lighthouse far away. Likewise, a dim nearby star might look similar to an enormous distant one. Distance itself remained hidden. For centuries, humanity stared into the universe without knowing its true scale. The night sky resembled a painted ceiling, beautiful, orderly, but perhaps flat. Then came one of the greatest revolutions in human thought. Astronomers discovered that the stars were not attached to a crystal sphere surrounding Earth. They occupied three-dimensional space. Some were relatively close. Others were separated by distances so enormous that light itself required years to travel between them. Suddenly, the familiar constellations became something unexpected. They were illusions. From Earth's perspective, stars seemed to form pictures: a hunter, a swan, a lion, a great bear. Yet in reality, those stars often have no relationship at all. They simply happen to line up from our viewpoint. If we could travel hundreds of light years away, every familiar constellation would dissolve into entirely different shapes. The pictures exist only because of where we happen to stand. This realization carried a quiet philosophical lesson. Perspective creates patterns. Change the perspective, and reality appears completely different. The universe had become deeper than anyone imagined. Still, astronomers refused to stop mapping. New instruments revealed stars invisible to the human eye. Small telescopes uncovered thousands. Larger observatories revealed millions, then billions. Every improvement expanded the known universe. Instead of approaching an edge, the map simply grew larger. Like explorers discovering that every mountain revealed another valley beyond it. The horizon continued retreating. Eventually, entire cloudy patches of light that once appeared insignificant were recognized as galaxies. Immense islands of stars drifting through space, each one containing hundreds of billions of suns. Our own Milky Way was no longer the universe itself. It was only one city among countless cosmic cities. Imagine standing on a beach. Each grain of sand beneath your feet represents a single galaxy. Now imagine trying to count every grain. Even that comparison barely hints at the immensity modern astronomy has uncovered. The map had become almost unimaginably vast. Yet something even stranger awaited discovery. As telescopes peered farther into the darkness, astronomers noticed that the universe did not simply continue outward. It also stretched backward through time. Because light travels at a finite speed, every distant object appears as it existed long ago. A star 1,000 light years away is seen 1,000 years in the past. A galaxy 10 million light years away appears 10 million years younger. The deeper we look into space, the further we look into history. A telescope is not merely a machine that magnifies distant objects. It is a time machine built from mirrors and patience. Every observation reveals another chapter of the universe's ancient story. Perhaps that is why mapping the cosmos feels unlike any other exploration. Most maps describe where things are. The universe asks us to map when they are as well. Distance and time become inseparable. Every point of light carries both an address and a memory. Even today, our greatest maps remain incomplete. Invisible dark matter shapes galaxies without revealing itself. Dark energy quietly drives the expansion of the cosmos. Entire regions remain forever beyond our ability to observe because their light has not yet reached us. There are boundaries to what we can see. but perhaps not to what actually exists. That possibility humbles every generation of astronomers. No matter how detailed our charts become, they may always represent only a tiny window into something vastly greater. The edge we continue searching for may not belong to the universe at all. It may belong only to our current understanding. And perhaps that is the most beautiful kind of map. Not one that claims to know everything, but one that quietly invites the next explorer to continue drawing beyond its borders. If these peaceful journeys through science and wonder help you relax or drift into thoughtful dreams, consider subscribing and joining us for many more quiet explorations beneath the stars, for time written across the cosmos. When you stand beneath a clear night sky, it is easy to believe that the stars exist only in the present moment. They shimmer with quiet certainty, appearing fixed and eternal, as though they have watched over every generation in exactly the same way. Yet, the remarkable truth hidden within the darkness is that every point of light is a messenger from another time. The universe does not simply surround us, it remembers. Every photon that finally reaches your eyes has traveled an extraordinary journey, preserving a tiny fragment of cosmic history until the instant you notice it. Imagine holding an old family photograph that has faded with age. The people inside that picture remain forever frozen in a single afternoon that can never be revisited. In many ways, every observation astronomers make is like opening another photograph from an unimaginably vast album. The moon appears only a little more than 1 second in the past because its reflected sunlight reaches Earth almost instantly. By cosmic standards, the sun you see hanging in the daytime sky actually belongs to 8 minutes ago. If the sun could somehow disappear without warning, Earth would continue receiving its light for those final 8 minutes before darkness arrived. Even our nearest stellar neighbor beyond the sun sends us light that has spent more than 4 years crossing the emptiness between stars. This realization transforms the night sky into something profoundly different from what our ancestors first imagined. They believed the heavens formed an unchanging dome above the Earth. Today, we understand that every direction we look becomes a different window into history. Nearby stars reveal relatively recent chapters. Distant galaxies unveil events that unfolded millions or even billions of years before humanity existed. Looking farther into space is not merely traveling across distance. It is traveling backward through time. This strange relationship between distance and time emerges because light, although unimaginably fast, still possesses a finite speed. Moving at nearly 300,000 kilometers every second, it seems almost instantaneous in everyday life. It circles Earth more than 7 times in a single second. Yet the universe is so vast that even light requires years, centuries, or entire ages to complete its journey. Space itself stretches the paths that light must travel, turning every observation into a delayed message from the past. The concept becomes even more astonishing when we begin observing galaxies beyond our own Milky Way. Some of these graceful islands of stars are so distant that their light departed long before the first mammals walked across Earth. Others began their journey before our planet even formed. Modern observatories routinely capture light that has traveled for more than 13 billion years. Those ancient photons started their voyage when the universe itself was still astonishingly young. It is almost impossible for the human mind to grasp such timescales because our lives unfold within decades rather than billions of years. History books describe civilizations lasting thousands of years as ancient beyond imagination. Mountains feel permanent because they endure for millions of years. Yet, compared with the age of the universe, even entire continents are fleeting features in an ever-changing cosmic story. This perspective invites an unusual kind of humility. Every concern that occupies a single afternoon, every season that feels endlessly long, every generation convinced it stands at the center of history exists within only the tiniest fraction of cosmic time. The stars remind us that existence extends far beyond human memory. Long before our species emerged, galaxies were already forming magnificent spirals, stars were living and dying, and planets unknown to us circled distant suns beneath skies that no human eyes would ever witness. Astronomers often describe telescopes as time machines, not because they transport us physically into the past, but because they allow ancient light to complete its journey. Each improvement in telescope technology extends our historical vision a little farther backward. Larger mirrors collect fainter light. More sensitive detectors reveal objects once hidden within darkness. Space telescopes avoid Earth's turbulent atmosphere, allowing them to capture incredibly delicate signals that have traveled across nearly the entire observable universe. As these instruments peer deeper into space, they encounter galaxies unlike those surrounding us today. Young galaxies appear smaller, more chaotic, and filled with intense bursts of star formation. They reveal a universe still assembling its grand architecture. Spiral galaxies had not yet settled into elegant shapes. Massive clusters were only beginning to gather. The cosmos itself looked remarkably different from the familiar landscape we observe nearby. In this way, the universe becomes its own historical record. Geologists study layers of rock to reconstruct Earth's past. Paleontologists uncover fossils that preserve ancient life. Historians examine manuscripts and monuments left behind by civilizations. Astronomers need only observe deeper into space. The evidence remains suspended above us, carried continuously by streams of ancient light that arrive every second without interruption. Even darkness tells part of the story. Vast clouds of gas and dust drift between stars, hiding newborn stellar nurseries from ordinary view. Infrared telescopes can penetrate these veils, revealing stars just beginning their existence. Elsewhere, brilliant explosions known as supernovae briefly outshine entire galaxies before fading forever. Their light races outward across space, announcing the death of massive stars long after the events themselves have concluded. Perhaps the most poetic aspect of all is that the atoms composing our own bodies share the same history. The carbon within every living cell, the oxygen we breathe, the calcium inside our bones were all forged within ancient stars that lived and died billions of years ago. Their explosive endings scattered these elements across space, where they eventually became part of new generations of stars and planets. Our existence is not separate from cosmic history. We are one of its latest chapters. Every evening, when sunlight fades and the stars quietly emerge, an invisible archive opens once more above our heads. No shelves hold its volumes. No librarian arranges its collection. Instead, every beam of light becomes a sentence. Every galaxy, another page. Every constellation, another reminder that time itself can travel across unimaginable distances. The night sky is not merely beautiful because of what it contains. It is beautiful because it allows us to witness history unfolding across the greatest stage imaginable, inviting us to read stories written not with ink, but with light itself. 5 invisible forces that shape everything. The universe is guided less by what we can see than by forces we can barely detect. The greatest architects of reality may forever remain invisible. Throughout history, humanity has trusted its eyes more than any other sense. We believe mountains are solid because we can touch them. We know oceans exist because we can watch their waves. The stars fill the night sky with dazzling beauty because light carries their presence across unimaginable distances. Yet modern science has revealed a quiet paradox. Almost everything we experience depends upon things we cannot see. The air surrounding you has no color, yet without it, every living creature would vanish within minutes. Magnetic fields silently guide compass needles across the globe, though they remain completely invisible. Radio waves pass effortlessly through the room around you, carrying voices, music, and information without ever revealing themselves to human sight. Reality has always been richer than our senses allow. The universe simply waited for us to discover that truth. Perhaps no invisible force has shaped our understanding of existence more profoundly than gravity. Every child learns that objects fall toward the ground. The lesson appears almost too ordinary to deserve much thought. But gravity is doing far more than pulling apples from trees. At this very moment, it holds your feet gently against Earth. It keeps the moon faithfully circling our planet. It binds Earth to the sun. It gathers hundreds of billions of stars into the graceful spiral we call the Milky Way. It choreographs the slow dance of galaxies across billions of light years. Without gravity, there would be no planets, no stars, no galaxies, no people wondering about the cosmos. Yet gravity itself remains invisible. We never actually see it. We witness only its effects. Imagine tossing a stone into a perfectly still pond. Ripples spread outward across the water, revealing where the stone entered. Gravity behaves somewhat like those ripples, although not through water, but through the very fabric of space and time. Mass bends the geometry of the universe itself. Planets do not simply travel because some mysterious force pulls them forward. Instead, they follow gentle curves created by the shape of space-time. It is an idea so strange that even many scientists struggled to accept it when it was first proposed. Yet countless observations have confirmed its remarkable accuracy. Light itself bends around massive galaxies. Entire clusters of stars act like gigantic cosmic lenses, magnifying even more distant objects hidden behind them. The invisible announces itself through subtle distortions. Sometimes the universe reveals its secrets not by direct observation, but through careful attention to small details. This lesson appears again and again throughout astronomy. As telescopes improved during the 20th century, astronomers expected the universe to become increasingly understandable. Instead, it became even stranger. They carefully measured how quickly stars moved around the centers of galaxies. According to everything visible, the outer stars should have traveled much more slowly than those near the center. That is how gravity behaves within familiar systems. Mercury races rapidly around the Sun. Neptune moves much more slowly. Distance weakens gravitational influence. Yet galaxies refuse to obey those expectations. Stars near their outer edges moved far too quickly. Fast enough that entire galaxies should have flown apart long ago. But they did not. Something unseen was holding them together. Something enormous, something invisible. Scientists eventually gave this mysterious substance a surprisingly simple name: dark matter. Not because it is black, not because it absorbs light, but because it remains hidden from every telescope designed to detect ordinary matter. No one has ever photographed dark matter directly. No one has held it in their hands, yet nearly every observation suggests it exists. Galaxies behave as though vast invisible halos surround them. Clusters of galaxies reveal far more gravity than their visible stars can possibly produce. Even the large-scale structure of the universe appears shaped by this unseen ingredient. Current estimates suggest that everything we can observe, every star, every planet, every cloud, every person, every living creature, accounts for only a small fraction of all matter in existence. The overwhelming majority may belong to something humanity has never directly encountered. Imagine entering an enormous cathedral while carrying only a tiny candle. The light reveals nearby columns and walls. You begin sketching a map based on what you can see. Only much later do you realize the darkness concealed most of the building. Our understanding of the cosmos may still resemble that first incomplete sketch. Visible matter illuminates only part of the greater structure. The unseen remains vast. Yet, the mysteries do not end there. Toward the close of the 20th century, astronomers uncovered another astonishing surprise. For decades, they assumed gravity would gradually slow the expansion of the universe. After all, gravity attracts. It pulls objects together. Common sense suggested that cosmic expansion should become increasingly gentle over time. Instead, careful observations revealed precisely the opposite. The universe is expanding faster today than it did billions of years ago. Some unknown influence appears to be pushing space itself apart. Scientists name this phenomenon dark energy. The title sounds dramatic, yet it simply acknowledges our ignorance. We know it exists because we observe its consequences. We do not yet understand what it truly is. If dark matter quietly gathers galaxies together, dark energy slowly encourages the universe to spread farther apart. Together, these invisible influences dominate the cosmos. Everything visible, the magnificent stars, colorful nebulae, glowing galaxies that fill breathtaking astronomical photographs, represents only a small portion of reality. The greatest architects remain hidden behind the scenes. There is something quietly humbling about this realization. For centuries, humanity believed that seeing was equivalent to knowing. Today, science teaches a gentler lesson. Observation is only the beginning. Sometimes the universe whispers rather than speaks. Sometimes it reveals itself only through delicate patterns that emerge after decades of patient measurement. Sometimes the most important discoveries arise from noticing that reality refuses to behave exactly as expected. Perhaps this is why astronomy remains such a deeply human pursuit. Every generation inherits mysteries that seem impossible. Then, little by little, careful observation transforms impossibility into understanding. Questions once considered magical become measurable. Invisible forces become mathematical descriptions. Yet every answer opens another doorway into even greater unknowns. The universe never seems offended by our curiosity. Instead, it rewards patience. It invites us to look more carefully, to question more deeply, to remain comfortable with uncertainty. Perhaps that is the greatest lesson hidden among the stars. Reality is not limited by the boundaries of our senses. The cosmos has never promised to reveal all of itself at once. Instead, it offers glimpses. A bent beam of light, a galaxy spinning too quickly, a universe expanding more rapidly than expected. Small clues scattered across unimaginable distances. Like footprints left by invisible travelers, they remind us that the greatest forces shaping existence may never appear directly before our eyes. And yet, through reason, imagination, and generations of quiet observation, humanity continues to trace their presence, slowly illuminating the unseen architecture upon which the entire universe has always rested. 6. When galaxies become islands. Every galaxy seems impossibly full. Billions, sometimes trillions, of stars drift together in slow gravitational dances. Nebulae bloom with newborn suns. Ancient clusters orbit silently around invisible centers. Black holes anchor the hearts of these enormous systems, like unseen monarchs ruling kingdoms of light. If you lived inside a single galaxy for your entire existence, you might believe the universe itself is crowded. You would be surrounded by stars in every direction. Light would dominate your nights. Distances between neighboring stars would already seem unimaginable. Yet compared with the spaces beyond your galaxy, they would almost feel intimate. Because the true loneliness of the universe does not begin between stars. It begins between galaxies. Imagine shrinking the Milky Way until it becomes the size of a single coin resting on a vast football field. The nearest large galaxy, Andromeda, would not sit beside it. It would lie dozens of meters away, across empty ground. Between those two coins, there would be almost nothing. Not planets, not stars, not glowing clouds, just darkness so complete that human intuition struggles to comprehend it. Astronomers call these immense regions intergalactic space. but that name hardly captures their emotional impact. They are not merely empty gaps separating islands of matter. They are oceans whose scale exceeds every ordinary comparison. Light itself takes millions of years to cross them. The nearest major galaxy to our own is approximately 2.5 million light-years away. That means every photon arriving from Andromeda tonight began its journey before our ancestors discovered agriculture, before cities, before writing, before civilization itself. When that light departed, humanity had not yet built monuments or kingdoms. Entire species that now dominate Earth had not yet evolved into recognizable forms. And still, those photons continued across unimaginable darkness, never stopping, never turning, never slowing, each one carrying a message that would not be read until millions of years later. This changes how we should think about distance. On Earth, we measure separation in kilometers. Within our solar system, we measure it in astronomical units. Between stars, we measure it in light years. But between galaxies, even light years begin to feel too small. Cosmic geography stretches language beyond its comfort. The emptiness separating galaxies is not simply larger than what we know. It belongs to an entirely different category of existence. Yet something remarkable happens inside this apparent nothingness. It is not perfectly empty. Scattered throughout intergalactic space are lonely hydrogen atoms drifting so far apart that two particles may remain separated by hundreds of cubic centimeters of vacuum. There are magnetic fields so weak they challenge detection. There are ghostly streams of hot plasma connecting clusters like invisible rivers. There are cosmic rays racing near the speed of light, crossing distances that would outlast civilizations. Even the greatest voids are never completely silent. Modern astronomy has revealed an intricate structure hidden beneath the apparent emptiness. Galaxies do not float randomly through space. Instead, they gather into enormous clusters. Clusters connect into gigantic superclusters. Superclusters themselves are woven together by colossal filaments, stretching across hundreds of millions of light years. Seen from far enough away, the universe resembles an immense three-dimensional web. Scientists call this the cosmic web. Its threads contain nearly every galaxy we have ever observed. Its intersections become cities of galaxies, where thousands of enormous systems crowd together under overwhelming gravity. Between those threads lie gigantic voids. These voids are among the largest known structures in existence. Some span hundreds of millions of light years across. If our Milky Way somehow drifted into one of these cosmic deserts, the night sky would become almost unimaginably empty. Many galaxies we currently see would disappear entirely. The universe would appear abandoned. Civilizations born inside such isolation might spend countless generations believing they existed alone. They might never realize that beyond their vast darkness, trillions upon trillions of stars continued shining forever out of sight. In this way, location shapes knowledge. Even intelligence depends on perspective. A civilization's understanding of reality may be limited not by its technology, but by where chance placed its home. This possibility reminds us of our own situation. Humanity occupies no privileged position. We happen to reside inside one spiral galaxy, among perhaps hundreds of billions. That galaxy belongs to a modest local group. The local group belongs to an even larger supercluster. The supercluster forms only one tiny knot within the cosmic web. Every map we create reveals another larger structure surrounding the previous one. Each discovery shrinks our sense of importance while expanding our appreciation of complexity. But perhaps the most astonishing realization concerns motion. Galaxies are not standing still. The universe itself expands. Every distant galaxy is generally moving away from every other galaxy because space between them continually stretches. This is not like explosions throwing objects outward through empty space. Instead, space itself grows. Imagine drawing dots across the surface of an inflating balloon. As the balloon expands, every dot moves farther away from every other dot. Not because the dots crawl across the surface, but because the surface itself stretches beneath them. Our universe behaves similarly, except in 3 dimensions. The consequence is extraordinary. Many galaxies recede from us so rapidly that the light they emit becomes stretched into longer wavelengths. This phenomenon, known as redshift, serves as one of the strongest pieces of evidence that the universe has been expanding for billions of years. But expansion carries another surprising implication. There are galaxies whose light will never reach us, not because they travel faster than light through space, but because expanding space continually increases the distance between us faster than light can bridge it. Their photons begin journeys they will never finish. Those galaxies remain forever beyond our observable horizon. No telescope, regardless of future technology, can retrieve information that never arrives. In a profound sense, parts of the universe are permanently inaccessible, not hidden, simply unreachable. Reality itself contains regions forever beyond observation. This realization transforms the concept of an observable universe. The observable universe is not the entire cosmos. It is merely the portion whose ancient light has had enough time to arrive since the beginning of cosmic expansion. Beyond that horizon may exist countless additional galaxies, additional clusters, additional webs extending without end, or perhaps entirely different cosmic landscapes. We simply do not know. The universe withholds that answer. This uncertainty reveals something deeply philosophical. Knowledge always has boundaries. No matter how advanced science becomes, some horizons may remain fixed, not because human curiosity fails, but because nature itself limits what information can travel. The universe permits questions whose answers can never be observed directly. Rather than diminishing science, this makes scientific exploration even more remarkable. Within finite limits, humanity has reconstructed the history of stars, galaxies, black holes, and cosmic evolution using nothing more than faint light arriving across billions of years. Every telescope becomes a translator. Every observation deciphers another sentence written across the darkness. Every discovery expands not only our understanding, but also our awareness of how much remains unknown. Perhaps that is the greatest lesson hidden among these galactic islands. Isolation does not imply insignificance. Distance does not erase connection. Although galaxies drift millions of light years apart, they remain threads woven into the same immense cosmic tapestry. Gravity links them, expansion shapes them, time records them. The atoms inside our bodies were forged within ancient stars that belonged to earlier generations of galaxies. The calcium in our bones, the oxygen we breathe, the iron flowing through our blood all originated in stellar furnaces long before the Earth existed. Even separated by impossible distances, every galaxy participates in the same universal story. We are not strangers looking across an empty sea. We are descendants of the same cosmic ancestry, temporarily living on one small shore, while countless distant islands continue their silent journeys through an ocean without end. 7. The language hidden inside nature. Perhaps the deepest mystery is not that mathematics works, but that it works everywhere. Whether we observe the graceful curve of a spiral galaxy, the delicate symmetry of a snowflake, or the invisible dance of electrons around an atomic nucleus, the same language quietly appears beneath them all. Numbers, ratios, patterns, equations. Human civilizations developed thousands of spoken languages. Every culture created its own words, stories, and symbols. Yet regardless of where a scientist is born, the equation describing gravity remains exactly the same. The geometry of a circle never changes. The value of pi does not depend on history, politics, or belief. It almost feels as though mathematics exists independently of humanity, patiently waiting to be discovered. Imagine walking into an ancient forest. You did not create the trees simply because you found them. They were already there long before your arrival. In much the same way, many mathematicians have wondered whether mathematical truths existed billions of years before life emerged on Earth. If no conscious beings had ever evolved, would 2 plus 2 still equal 4? Would prime numbers still stretch infinitely into eternity? Would the elegant relationships hidden inside geometry still shape every planet, every star, every galaxy? These questions sound philosophical, yet they quietly sit beneath modern science. Physics does not merely use mathematics as a convenient tool. In many cases, reality seems almost obligated to obey it. The orbit of Earth around the Sun follows mathematical laws with astonishing precision. The vibrations of atoms can be predicted mathematically. The bending of light near a black hole can be calculated long before telescopes observe it. Again and again, equations written on paper somehow become accurate descriptions of distant corners of the universe that no human has ever visited. Why? Some thinkers have suggested that mathematics is humanity's greatest invention, a language so flexible that we naturally adapt it to describe whatever we encounter. Others argue something far stranger. Perhaps mathematics is woven into reality itself. In this view, we are not inventing equations. We are translating them. The universe has been speaking this silent language since the first fraction of a second after the Big Bang. Every galaxy, every atom, every pulse of energy follows an invisible grammar that existed long before the first human looked up at the night sky. This idea becomes even more fascinating when we consider how often mathematics predicts discoveries before observations confirm them. Entire planets have been discovered because astronomers noticed tiny mathematical irregularities in the motion of other worlds. Particles were predicted decades before experiments finally revealed them. Even black holes, once dismissed as absurd consequences of Einstein's equations, eventually revealed themselves to be very real objects scattered throughout the cosmos. It is almost as if mathematics whispers secrets before nature allows us to see them. The more deeply science explores reality, the more abstract mathematics becomes. Negative numbers once seemed imaginary. Complex numbers were considered impossible because they involved the square root of -1. Higher dimensional geometry appeared to be nothing more than intellectual play. Yet all of these strange mathematical ideas eventually found unexpected homes inside physics. Without complex numbers, quantum mechanics would collapse. Without higher dimensional mathematics, modern theories attempting to unify gravity with quantum physics become nearly impossible. Ideas once dismissed as fantasy quietly became essential descriptions of reality. Perhaps this should make us humble. When today's mathematicians explore structures that seem completely detached from the physical world, they may unknowingly be mapping parts of reality that future generations will someday discover. Nature itself seems remarkably economical with mathematics. Across countless systems, simple rules generate astonishing complexity. A single equation can produce endlessly intricate fractals. Tiny changes in initial conditions can create weather systems spanning continents. Simple genetic instructions produce forests, whales, birds, and human brains. Order emerges from simplicity in ways that continue to surprise researchers. This recurring elegance has inspired another remarkable question. Why is the universe understandable at all? There is no obvious reason why reality should permit intelligent beings to uncover its laws. The cosmos could have been governed by chaotic rules changing every moment. Gravity might have fluctuated randomly. The speed of light might have shifted unpredictably. Physical constants might have drifted without pattern. In such a universe, science would be impossible. No stable knowledge could ever accumulate. Yet our universe appears deeply consistent. The same physical laws that governed the birth of ancient galaxies continue to operate inside laboratories today. Light behaves the same way, whether it travels across a room or across billions of light years. Hydrogen atoms formed shortly after the Big Bang behave exactly like hydrogen atoms observed on Earth today. This consistency is what allows understanding to exist. It allows curiosity to grow into knowledge. It allows small minds living on a tiny planet to reconstruct events that happened billions of years before our species appeared. Perhaps that is one of the quiet miracles of existence. The universe is not merely vast, it is comprehensible, not completely, not perfectly, but enough for tiny islands of awareness like ourselves to gradually uncover its hidden structure. Still, every answer seems to reveal even deeper questions. Why do these mathematical relationships exist instead of others? Why do the constants of nature possess the values they do? Could entirely different mathematical universes also exist, following different rules beyond anything we can imagine? No one truly knows. The deeper we travel into science, the more mystery seems to expand alongside knowledge. Perhaps wisdom lies not in eliminating mystery, but in learning to appreciate it. Every equation solved opens another unopened door. Every discovery stretches the horizon a little farther away. The universe remains both understandable and endlessly mysterious at the same time. And maybe that balance is exactly what keeps curiosity alive. As we continue searching among stars, galaxies, and the invisible foundations of reality, we slowly realize that the greatest journey is not only through space, it is through understanding itself. If this calm exploration is helping you unwind after a long day, don't forget to subscribe so you never miss another peaceful voyage into the mysteries of existence. 8. The strange simplicity of cosmic laws. There's something quietly astonishing about the universe. Everywhere we look, we encounter unimaginable complexity. Galaxies containing hundreds of billions of stars drift through expanding space. Clouds of gas collapse into newborn suns. Planets develop climates, oceans, mountains, and perhaps even life. Inside every living cell, countless molecular machines perform their work with incredible precision. At first glance, reality appears overwhelmingly complicated. Yet, beneath all this richness, scientists continue discovering something unexpected. The rules themselves are remarkably few. The same force that causes an apple to fall from a tree guides the moon around Earth. The same gravity that shapes our daily lives governs the motion of galaxies, separated by millions of light years. The same electromagnetic force that allows electricity to flow through a small wire also powers the brilliant light emitted by distant stars. Nature does not seem to require countless independent laws for every situation. Instead, it repeatedly builds extraordinary diversity from a surprisingly small collection of fundamental principles. This simplicity is one of the greatest surprises in science. Imagine opening an enormous novel containing millions of pages. You might expect it to require an impossibly large alphabet. Instead, every word, every sentence, every chapter is built from only a few dozen letters arranged in different combinations. The universe appears to operate in much the same way. From a handful of particles and a small number of fundamental interactions emerges everything we have ever known. Mountains, clouds, trees, animals. Human minds capable of wondering about their own existence. None of these require entirely new laws of physics. They are different expressions of the same underlying reality. Perhaps this is why physicists often search for elegance rather than complexity. History has shown that nature repeatedly rewards simple explanations. When Isaac Newton described gravity with a single mathematical relationship, he united earthly motion and celestial motion for the first time. Before then, many believed that the heavens operated according to entirely different principles than life on Earth. Newton revealed something profoundly beautiful. the universe follows one consistent logic. Centuries later, James Clerk Maxwell performed another remarkable act of simplification. Electricity and magnetism had long been studied as separate phenomena. Through elegant equations, Maxwell demonstrated that they were simply different aspects of one unified force. Even more astonishingly, his equations predicted electromagnetic waves before anyone had ever generated or detected them. Radio, television, radar, wireless communication, and much of modern technology ultimately emerged from that quiet mathematical insight. Again and again, science advances not by adding endless complexity, but by uncovering deeper unity. Albert Einstein continued this tradition. Instead of viewing gravity as an invisible force pulling objects together, he described it as the curvature of space and time themselves. Mass tells space how to curve. Curved space tells matter how to move. An idea that initially sounded almost impossible eventually explained planetary motion, black holes, gravitational waves, and the expansion of the universe with extraordinary accuracy. The equations became simpler. The universe became deeper. This pattern raises an intriguing possibility. Perhaps simplicity is not merely convenient. Perhaps simplicity is fundamental. Nature often appears to prefer solutions that are economical. Soap bubbles naturally form shapes that minimize surface area. Light travels along paths requiring the least travel time. Planetary systems gradually settle into stable configurations. Even biological evolution often favors structures that accomplish more while using less energy. Efficiency quietly echoes throughout reality. This does not mean the universe is easy to understand. Simple rules can generate astonishingly complicated outcomes. Consider a snowflake. Every crystal begins with the same basic laws governing water molecules, yet no two snowflakes are perfectly identical. Tiny differences in temperature, humidity, and microscopic conditions create endless variety from identical physical principles. The same is true of clouds. The same equations governing fluid motion produce calm breezes, gentle rain, towering hurricanes, and swirling storms that span entire oceans. The laws remain unchanged. Only the circumstances differ. This idea appears again in mathematics. Some of the most intricate fractals ever discovered emerge from equations simple enough to fit on a single line. Repeat one instruction millions of times, and breathtaking complexity unfolds. Tiny rules become infinite patterns. The universe may work in much the same way. Perhaps galaxies, stars, planets, ecosystems, and civilizations are not exceptions to simple laws. Perhaps they are exactly what simple laws naturally produce when given enough time. Time itself becomes an essential ingredient. The universe has had nearly 14 billion years to explore the possibilities hidden inside its own rules. Small fluctuations after the Big Bang gradually became galaxies. Stars forged heavier elements. Exploding supernovae scattered those elements across space. New stars formed, surrounded by planets. Chemistry slowly evolved into biology. Biology eventually produced consciousness. Each step followed naturally from the previous one. No new physical laws had to appear. The same cosmic instructions continued unfolding chapter after chapter. This perspective changes the way we think about complexity. Rather than seeing life as something disconnected from physics, we begin to recognize continuity. Atoms become molecules. Molecules become cells. Cells become organisms. Organisms become civilizations. Civilizations become observers capable of reflecting upon the very universe that created them. The chain never breaks. Everything belongs to the same unfolding story. Yet despite these remarkable successes, science has not reached the end. Several pieces of the puzzle remain disconnected. Gravity fits beautifully within Einstein's description of space and time. Quantum mechanics describes the microscopic world with extraordinary precision. But these two powerful theories resist complete unification. Each works astonishingly well within its own domain. Together, however, they remain incomplete. This has inspired generations of physicists to search for an even deeper simplicity. Perhaps today's separate theories are merely fragments of one greater framework waiting to be discovered. History offers reasons for optimism. What once appeared unrelated has repeatedly turned out to be unified. Electricity and magnetism, space and time, mass and energy. Could gravity and quantum physics someday become different faces of the same underlying principle? No one knows. Yet the search continues because nature has repeatedly rewarded those who looked beneath apparent complexity for hidden simplicity. There is also something deeply comforting about this idea. Our daily lives often feel chaotic. Events seem disconnected. Problems arrive without warning. The world appears unpredictable. But beneath that surface, reality continues operating through quiet consistency. The atoms in your body obey the same laws as the stars. The photons entering your eyes have traveled according to principles established at the dawn of the cosmos. Every heartbeat, every breath, every thought depends upon rules that have remained astonishingly stable across billions of years. In a universe filled with uncertainty, those silent constants provide a kind of invisible foundation. Perhaps that is why so many scientists describe their work with a sense of wonder rather than certainty. Every elegant equation is not merely a calculation. It is a glimpse into the architecture of existence. Every law discovered reveals another layer of order hidden beneath apparent chaos. The search is never only about solving problems. It is about understanding why reality possesses such remarkable coherence in the first place. Maybe the greatest mystery is not that the universe is vast, nor that it contains countless galaxies beyond imagination. Perhaps the greatest mystery is that everything, from the smallest particle to the largest cosmic web, appears connected through an unexpectedly simple set of rules. A few elegant principles have written a story spanning billions of years. From those quiet beginnings emerged stars. From stars came planets. From planets came life. And from life came minds capable of asking why simplicity could create something so endlessly beautiful. The more carefully we observe the universe, the less it resembles a collection of separate objects. Instead, it begins to feel like a single symphony, performed with only a handful of notes, yet capable of producing melodies more intricate than anyone could have imagined. 9. The places light can never reach. There is a quiet assumption that has guided humanity for centuries. We believe that if something exists, then eventually we will be able to see it, perhaps with a better telescope, perhaps with a more sensitive detector, perhaps after enough time has passed. Science has repeatedly rewarded this optimism. Invisible planets were eventually discovered. Hidden galaxies emerged from darkness. Even black holes, once considered mathematical curiosities, revealed themselves through the influence they exerted on surrounding space. Again and again, improved instruments expanded the boundaries of the visible universe. Yet modern cosmology introduces a humbling possibility. Some parts of reality may remain forever beyond observation. Not because our technology is insufficient, not because we have failed to search carefully enough, but because the universe itself prevents their light from ever reaching us. Imagine standing on the shore of an endless ocean. Ships disappear over the horizon, not because they cease to exist, but because Earth's curvature hides them from view. No matter how carefully you stare across the water, there comes a point beyond which your eyes simply cannot see. The observable universe has a similar horizon. Light travels incredibly fast, moving nearly 300,000 kilometers every second. Even so, it requires time to cross the enormous distances between galaxies. Since the universe itself has existed for about 13.8 billion years, there is a natural limit to how far light could possibly have traveled. Everything whose light has reached us forms what astronomers call the observable universe. It is an immense sphere centered around every observer. From Earth, we can detect ancient light arriving from galaxies billions of light years away. We can even observe the faint afterglow left behind shortly after the Big Bang itself. Yet, beyond this cosmic horizon lies a profound mystery. The universe may continue far beyond everything we can ever observe. Perhaps infinitely far. Those distant regions are not hidden because they are dark. Their light simply has not had enough time to arrive. Even stranger, due to the expansion of space itself, some regions are receding from us so rapidly that their light never will. Every second, the observable universe changes. New light from nearby regions gradually reaches us. At the same time, unimaginably distant galaxies are carried farther away by cosmic expansion. Some eventually cross a boundary beyond which communication becomes impossible forever. Their future light can never catch up. It is a strange thought. Entire civilizations could someday exist around stars beyond our cosmic horizon. They might develop science. They might wonder about the universe. They might build telescopes as powerful as imagination allows. Yet neither they nor we could ever exchange a single photon. Our two regions of reality would remain forever isolated by the geometry of expanding space. This idea changes how we think about existence itself. For thousands of years, people naturally equated reality with observation. If something could not be seen, perhaps it was not there. Science has taught us otherwise. Atoms existed long before microscopes. Radio waves surrounded Earth before antennas detected them. Neutrinos streamed through our bodies for billions of years before anyone realized they existed. Again and again, reality proved larger than perception. Now, cosmology suggests an even deeper lesson. Reality may remain larger than observation forever. There may be truths that are not merely undiscovered. They may be permanently inaccessible. This possibility challenges the ambition of science in a surprisingly beautiful way. Science seeks understanding, but it also accepts limits. Knowing where knowledge must stop is itself a form of knowledge. The cosmic horizon is one such boundary. Beyond it, mathematics continues where observation cannot. Physicists construct models describing how the larger universe might behave. Some suggest that space extends infinitely. Others propose enormous regions with different properties beyond our observable domain. Still others imagine countless cosmic bubbles, each born from its own expansion, together forming what has become known as the multiverse. Whether these ideas are correct remains uncertain. Their greatest challenge is not imagination. It is evidence. If light from those regions can never reach us, direct confirmation becomes extraordinarily difficult. This does not necessarily make the ideas unscientific. Science often explores possibilities through indirect consequences. Just as invisible planets reveal themselves through gravitational influence, unseen regions of the universe might someday leave subtle fingerprints upon the observable cosmos. Researchers continue searching for such clues. So far, the answers remain elusive. Black holes introduce another fascinating example of places where light cannot carry information. Beyond the event horizon, gravity becomes so overwhelming that nothing traveling at or below the speed of light can escape. Any event occurring inside becomes permanently hidden from outside observers. To someone watching from afar, the interior remains inaccessible, not because it lacks activity, not because nothing happens there, but because information itself cannot return. It is almost as though the universe contains sealed chapters whose contents remain forever unread. Quantum physics adds another layer to this mystery. Some interpretations suggest that reality itself contains possibilities inaccessible from any single observer's perspective. Different measurements reveal different aspects of nature, while no observer can simultaneously access every piece of information. Even at the smallest scales, complete knowledge may be fundamentally limited. The universe appears comfortable preserving mystery. This realization need not feel discouraging, quite the opposite. Limits often create meaning. Imagine reading a novel whose every mystery was explained before the first chapter ended. Its wonder would quickly disappear. The unknown gives curiosity room to breathe. Every unanswered question invites another generation to continue exploring. Perhaps that is one reason science remains endlessly alive. No discovery marks the final page. Every answer quietly opens another door. There is also something deeply personal hidden within these cosmic horizons. Each human life possesses invisible regions as well. No matter how well we know another person, parts of their thoughts remain private. No matter how carefully we remember our own past, certain moments fade beyond recovery. Every mind contains landscapes that cannot be fully shared. Yet relationships remain meaningful despite these invisible boundaries. Perhaps the universe reflects the same truth? Complete access is not required for genuine understanding. We do not need to observe every galaxy to appreciate the grandeur of existence. We do not need every answer before wonder becomes worthwhile. In fact, wonder may depend upon the presence of unanswered questions. The night sky itself illustrates this beautifully. When we gaze upward, darkness dominates far more than light. Between brilliant stars stretches immense emptiness. Beyond visible galaxies lies an ocean our instruments cannot yet explore. Beyond the observable universe may extend realities forever beyond contact. Darkness is not simply the absence of information. Sometimes it is the boundary reminding us that existence extends farther than perception. Perhaps future generations will push these limits farther than we imagine today. New observatories may detect fainter signals. Gravitational waves may reveal structures invisible to ordinary light. Neutrinos may carry messages from environments no telescope can penetrate. Entirely new forms of observation may someday emerge. Human ingenuity has repeatedly transformed impossibilities into ordinary knowledge. Yet even with every future discovery, some horizons may remain. The universe seems determined to preserve distance as well as closeness, silence as well as revelation, hiddenness as well as visibility. There is a quiet elegance in that balance. The cosmos does not reveal everything at once. Instead, it offers glimpses. Each observation becomes a small window opened into an immeasurable reality. Each photon arriving from a distant star is both an answer and a reminder that countless other stories remain untold. Perhaps the most profound lesson is not that parts of the universe are forever hidden. It is that even within the small portion we can observe, there is already more beauty, complexity, and mystery than a single lifetime could ever fully comprehend. The light that reaches us has traveled across billions of years simply to arrive in our eyes for a brief moment. Beyond that light, the universe continues its silent unfolding, carrying histories we may never witness, civilizations we may never know, and wonders that may forever remain beyond the reach of every telescope humanity will ever build. And somehow, rather than making the cosmos feel smaller, those unseen places make it feel infinitely more alive. 10. The quiet birth of new universes. For most of human history, we naturally imagined that the universe was everything that existed. The stars above, the planets, the distant galaxies, and the vast stretches of empty space between them seemed more than enough to occupy our imagination. Even after telescopes revealed billions of galaxies scattered across the cosmos, we still spoke of the universe in the singular, as though all of existence belonged to one immense but complete story. Yet over the past few decades, a remarkable possibility has slowly emerged from theoretical physics. Perhaps our universe is only one chapter in a much larger collection. Perhaps reality extends beyond what we have always called the universe, giving rise to countless other cosmic realms, each with its own history, its own laws, and perhaps even its own version of time. This idea may sound like science fiction, but its roots lie in genuine attempts to understand how our own universe began. The Big Bang is often imagined as a gigantic explosion occurring inside empty space. In reality, it was something much stranger. Space itself expanded. Time itself unfolded. Matter and energy emerged as the young universe cooled, eventually forming stars, galaxies, planets, and every living creature that would one day gaze back toward the heavens. But what caused the Big Bang? That question remains one of the deepest mysteries in cosmology. Some theories suggest that the rapid expansion of the infant universe was driven by a brief period known as cosmic inflation. During this unimaginably tiny fraction of a second, space expanded at an extraordinary rate, smoothing out the young cosmos and planting the tiny fluctuations that would later grow into galaxies. Inflation successfully explains many features of the observable universe. Yet some versions of this theory carry an unexpected consequence. Inflation may never completely stop. While it ends in one region, allowing a universe like ours to form, it continues elsewhere. Those regions continue expanding until they too produce new universes. Then, still more regions repeat the process, again and again, without end. Imagine boiling water in a pot. As heat rises, bubbles appear throughout the liquid. Each bubble forms independently. Each grows according to the same underlying process. Although every bubble exists within the same pot, each possesses its own boundary, separated from the others. Some physicists have suggested that universes may emerge in a surprisingly similar way. Our cosmos could be one bubble among an unimaginably vast collection. Each bubble would possess its own expanding space, its own history, perhaps even its own physical constants. From inside one bubble, the others would remain forever unreachable. To observers living within them, each universe would appear complete. Few would suspect that countless neighboring realities quietly surrounded them beyond every possible horizon. If this picture is correct, then the question changes dramatically. Instead of asking why our universe possesses its particular properties, we begin asking why we happen to live in this one rather than another. This idea becomes especially intriguing when considering the delicate balance of nature. Many fundamental constants appear finely tuned. If gravity were slightly stronger, stars might burn too quickly. If it were weaker, galaxies might never form. If the electromagnetic force differed significantly, chemistry as we know it could become impossible. Tiny adjustments might prevent atoms from existing at all. Some scientists interpret this apparent balance as evidence that only one set of constants is possible. Others suggest something different. Perhaps countless universes exist, each with different values. Most remain lifeless. A few accidentally possess the conditions necessary for complexity. Naturally, conscious observers would only arise in those rare universes capable of supporting them. It is similar to finding yourself on an island with fresh water and fertile soil. You might wonder why this island is so perfectly suited for life. The answer may not be that every island is equally welcoming. Rather, only on such an island could anyone survive long enough to ask the question. This reasoning is known as the anthropic principle. It remains both influential and controversial. Some scientists appreciate its explanatory power. Others argue that it risks replacing deeper understanding with philosophical convenience. The debate continues. Yet regardless of where one stands, the possibility of multiple universes encourages remarkable humility. Everything we consider universal may apply only locally. Our laws of physics, our dimensions of space, even the flow of time itself. In another universe, these familiar foundations might look entirely different. Imagine a cosmos with 4 large spatial dimensions instead of 3. Planets might never form stable orbits. life, if possible at all, would likely bear no resemblance to anything we know. Or imagine a universe where gravity is dramatically weaker. Stars could become enormous, diffuse clouds lasting trillions of years. Perhaps civilizations there would experience a night sky unlike anything imaginable on Earth. Some theoretical models go even further. String theory suggests that reality may contain additional hidden dimensions curled into unimaginably tiny scales. Different ways of folding these dimensions could produce entirely different physical laws. If so, each newborn universe may inherit its own unique structure from the geometry hidden deep within space itself. Of course, all of this remains speculative. No telescope has directly observed another universe. No spacecraft could ever travel beyond the expanding boundaries of our own cosmic domain. The challenge is profound. By definition, other universes may never exchange light or information with ours. Their existence, if real, may always remain indirect. Yet science has often confronted invisible realities before. Long before electrons were observed, their effects were measurable. Before gravitational waves were detected, Einstein's equations predicted them for a century. Invisible does not necessarily mean non-existent. It simply demands greater patience. Perhaps future discoveries will reveal subtle traces left by neighboring universes. Some cosmologists have searched for unusual patterns in the cosmic microwave background that might hint at ancient collisions between expanding cosmic bubbles. So far, no conclusive evidence has emerged, but the search continues. Whether it succeeds or not, the effort itself reflects something deeply human. Curiosity does not stop at boundaries. Whenever one horizon appears, we naturally wonder what lies beyond. When ancient sailors reached the edge of familiar maps, they imagined unknown continents. When astronomers discovered our galaxy, they wondered whether others existed. When galaxies themselves filled the observable universe, our imagination stretched once again. Each generation inherits a larger horizon than the last. Perhaps that journey will never truly end. There is also something quietly poetic about the idea of new universes being born. Our own cosmos began in extraordinary simplicity. No stars, no planets, no oceans, no living creatures. Only an expanding sea of energy gradually cooling through time. Given enough patience, gravity sculpted galaxies. Stars ignited. Heavy elements formed. Worlds emerged. Eventually, somewhere on one ordinary planet, orbiting one ordinary star, consciousness awakened. If new universes continue forming elsewhere, perhaps this story repeats in countless variations. Some may remain dark forever. Others may create galaxies unlike our own. A few might nurture forms of life so different that even the concept of biology scarcely applies. Some may never know stability. Others could endure far longer than ours. Each would be a unique expression of possibility. And yet, despite these grand speculations, there is an unexpected lesson hidden within them. Whether our universe is one among many, or the only one that exists, the experience of living within it remains equally precious. Every sunrise still warms the same earth. Every heartbeat still depends upon the same ancient atoms forged inside forgotten stars. Every human question still emerges from minds shaped by billions of years of cosmic history. The possibility of countless universes does not diminish the beauty of this one. Instead, it magnifies it. Among all the realities that might exist, this is the one whose light reaches our eyes. This is the universe whose stars illuminate our nights. This is the cosmos whose laws allow us to breathe, to wonder, and to search for meaning. Perhaps somewhere beyond every observable horizon, new universes are quietly coming into existence even now, each beginning its own long journey from simplicity toward complexity. If that is true, then creation may not have been a single event in the distant past. It may be an endless process, unfolding silently across realities forever hidden from one another. And somewhere, in one of those newborn universes, beneath an unfamiliar sky, filled with stars unlike any we have ever seen, another curious mind may someday look upward and ask the very same question that has echoed across humanity for centuries. Is this all there is? Or is reality far greater than anything we can possibly imagine? 11. The limits of human understanding. For centuries, humanity has celebrated every great scientific discovery as though it brought us one step closer to knowing everything. When Newton described gravity, it seemed that the motion of the heavens had finally become understandable. When Maxwell united electricity and magnetism, invisible forces suddenly obeyed elegant mathematical rules. When Einstein reshaped our understanding of space and time, reality itself appeared more coherent than ever before. Every generation has experienced moments when it seemed the universe was finally revealing its deepest secrets. Yet history tells a different story. Every answer has uncovered even greater questions. Every solved mystery has exposed an even larger horizon waiting beyond it. Science does not simply reduce ignorance. Paradoxically, it often expands our awareness of how much remains unknown. Imagine standing inside a vast cave with only a small lantern. At first, the light reveals almost nothing. You assume the cave is tiny because you can see so little. As your lantern grows brighter, more walls become visible. More passages appear. Hidden chambers emerge from darkness. The cave seems to grow larger precisely because your vision has improved. Knowledge behaves in much the same way. The more humanity learns about the universe, the larger reality appears to become. Ancient astronomers believed Earth stood at the center of everything. The stars revolved overhead like decorations fixed upon a great celestial sphere. The universe seemed orderly, understandable, and comfortably small. Then telescopes arrived. Earth became one planet among many. The sun became one ordinary star. Our galaxy became one among hundreds of billions. Each discovery made humanity less central, yet the universe infinitely richer. Today, we understand more about nature than any previous civilization. We can detect gravitational waves from colliding black holes billions of light years away. We can measure the faint radiation left behind shortly after the Big Bang. We can observe planets orbiting distant stars and even analyze the chemistry of their atmospheres. Quantum mechanics accurately predicts phenomena occurring inside atoms. General relativity explains the motion of galaxies and the bending of space-time itself. These achievements are extraordinary, yet together they reveal something surprising. Our two greatest theories remain fundamentally incomplete. Quantum mechanics governs the smallest scales with astonishing precision. General relativity describes gravity across the largest structures in the universe with equal success. Individually, both theories work beautifully. Together, they refuse to fit. When physicists attempt to combine them under the extreme conditions inside black holes, or during the first moments after the Big Bang, the mathematics breaks apart. Reality seems to speak two different languages. Both appear correct. Neither fully explains the other. Somewhere beyond our current understanding, a deeper theory almost certainly exists. Finding it has become one of the greatest scientific quests of our time. Yet even if such a theory were discovered tomorrow, history suggests it would not represent the end. Instead, it would almost certainly reveal entirely new mysteries that we cannot yet imagine. There is another limit that science encounters. Some questions may simply lie beyond experimental reach. Consider the earliest fraction of a second after the Big Bang. Temperatures were so unimaginably high that no existing laboratory can reproduce them. The conditions existed only once in the observable history of our universe. Physicists must reconstruct those moments using mathematics, indirect observations, and careful reasoning. Similarly, the interiors of black holes remain hidden behind event horizons. Information cannot escape. No telescope will ever watch what truly happens inside. Some aspects of reality may therefore remain permanently inaccessible, not because science has failed, but because nature itself imposes boundaries. Even mathematics introduces unexpected limitations. In the early 20th century, the mathematician Kurt Gödel demonstrated something astonishing. Within any sufficiently powerful mathematical system, there exist true statements that cannot be proven using the rules of that system alone. No matter how complete the system appears, certain truths always remain beyond formal proof. This discovery shocked mathematicians because it suggested that absolute completeness is impossible. Perhaps knowledge itself possesses unavoidable edges. If mathematics has limits, it is reasonable to wonder whether science does as well. Our own minds may represent another boundary. The human brain evolved to survive on the African savanna. It became remarkably skilled at recognizing faces, throwing objects, predicting movement, and cooperating with other people. Nothing in evolution required humans to intuitively understand quantum fields, curved space-time, or 11-dimensional geometry. The fact that we can study these subjects at all is extraordinary. Yet there may exist concepts that simply exceed our natural cognitive architecture. Imagine asking a goldfish to understand calculus. No matter how intelligent the fish becomes within the limits of its biology, certain abstractions may forever remain inaccessible. Likewise, humanity may someday encounter ideas that our brains cannot fully grasp. Perhaps advanced civilizations elsewhere have already crossed intellectual thresholds impossible for us to imagine. Perhaps they perceive aspects of reality that remain invisible not only to our instruments, but also to our intuition. This possibility is both humbling and inspiring. It reminds us that intelligence itself exists on a spectrum. Our current understanding may represent only one stage in a much longer journey. Technology continually extends the reach of our senses. Our eyes cannot detect radio waves, yet radio telescopes reveal entire galaxies. We cannot feel gravitational waves, yet laser interferometers measure distortions smaller than atomic nuclei. Artificial intelligence already assists scientists in recognizing patterns too subtle for unaided human analysis. Perhaps future generations will build machines capable of exploring realities that biological minds alone could never comprehend. Even then, the horizon may simply move farther away. Knowledge appears to behave like the edge of the sea. As you walk toward it, the horizon retreats. You never arrive. The journey itself becomes the destination. There is something deeply comforting about this endless process. Many people imagine uncertainty as weakness. Science teaches the opposite. The willingness to admit uncertainty has always been its greatest strength. Every scientific theory remains open to revision. Every conclusion invites further testing. Certainty belongs not to science, but to dogma. Progress depends upon recognizing the possibility of being wrong. Perhaps this explains why scientific knowledge grows so steadily across generations. Each discovery becomes a foundation rather than a final answer. Young researchers inherit questions their teachers could not solve. Future generations will inherit questions that we have not yet learned to ask. The chain continues without end. There is also a philosophical lesson hidden within these limits. Human beings often seek complete explanations because certainty feels safe. We want reality to fit neatly inside understandable categories. Yet the universe appears far more generous than our desire for simplicity. It offers elegance without complete transparency, order without total predictability, beauty without final explanation. The unknown is not an obstacle standing outside knowledge. It is the landscape in which knowledge grows. If every mystery vanished tomorrow, curiosity itself might disappear. There would be no new frontiers, no unanswered questions, no reason to build larger telescopes or devise more imaginative theories. Wonder depends upon the existence of what remains hidden. Perhaps that is why every generation continues looking upward. children gaze at the stars with questions that adults still cannot answer. Scientists spend entire careers investigating tiny pieces of enormous puzzles. Philosophers continue asking questions first spoken thousands of years ago. What is consciousness? Why does anything exist at all? Why do the laws of nature possess the form they do? Some questions may accompany intelligent life forever. That possibility does not diminish their value. Instead, it gives them extraordinary depth. In the end, the greatest achievement of science may not be that it explains the universe. Its greatest achievement may be teaching us how to live gracefully with uncertainty. It transforms mystery from something frightening into something beautiful. Every unanswered question becomes an invitation rather than a defeat. Every horizon becomes a promise that there is still more to discover. Perhaps that is the quiet wisdom hidden behind every scientific breakthrough. The universe does not become smaller as we understand it. It becomes larger. Each new discovery illuminates another corner of reality, while revealing countless others still waiting in darkness. And somewhere beyond the limits of today's knowledge, beyond equations not yet written, and observations not yet made, the universe patiently keeps its remaining secrets, not to frustrate our curiosity, but to ensure that the journey of discovery never truly comes to an end. 12. When reality defies intuition. There is something strangely comforting about common sense. It tells us that solid objects are truly solid. It tells us that time flows steadily from yesterday into tomorrow. It tells us that space is simply an empty stage upon which everything happens. Every moment of our daily lives reinforces these beliefs. We walk across the floor without questioning whether it will support us. We watch clocks measure the passing hours with reassuring regularity. We throw a ball and expect it to follow a graceful arc through the air. Our intuition works remarkably well. It evolved over millions of years to help our ancestors survive in a world of forests, rivers, mountains, and predators. Natural selection rewarded brains that could accurately predict everyday events. It never prepared us to understand the deepest workings of the cosmos. As physics ventured further into reality, scientists encountered something profoundly unexpected. Nature did not behave according to human intuition. Instead, it followed rules that seemed almost impossible to believe. Take the simple act of touching a table. It feels perfectly solid beneath your hand. Yet atoms, which make up the table, are mostly empty space. If the nucleus of an atom were enlarged to the size of a marble resting at the center of a great stadium, the electrons would occupy regions near the outer seats, leaving almost everything in between completely empty. Why then does the table feel solid? Not because particles physically touch one another. Rather, invisible electromagnetic forces prevent the atoms in your hand from passing through the atoms in the wood. What feels like contact is actually a delicate balance of fundamental forces. Even the certainty of location begins to disappear under closer examination. In everyday life, every object occupies a definite place. A cup sits on the desk. The moon circles Earth. A bird flies across the sky. Quantum physics tells a more mysterious story. Before measurement, tiny particles are described not by exact positions, but by probabilities. They exist as possibilities spread across space. Only when an interaction occurs does one particular outcome become part of observable reality. This does not mean particles are indecisive. It means nature itself operates according to principles unlike anything our intuition evolved to understand. Light provides another astonishing example. For centuries, scientists argued whether light behaved as a wave or as tiny particles. The surprising answer turned out to be both. Under some experiments, light spreads like ripples across a pond. Under others, it arrives as individual packets of energy called photons. Neither picture alone tells the complete story. Reality quietly refuses to fit inside categories that human language finds comfortable. The deeper physicists investigated matter, the stranger everything became. Electrons possess an intrinsic property called spin. Yet this spin does not resemble the spinning motion of a toy top. It represents something entirely different, something without a perfect analogy in ordinary experience. The mathematics describes it precisely. Our imagination struggles to picture it. Perhaps imagination was never meant to. Time itself begins to lose its familiar character. Most people imagine the present as a universal moment shared throughout the cosmos. It feels obvious that everyone experiences the same now. Einstein showed otherwise. Two observers moving differently through space can disagree about the timing of events. For one observer, two lightning strikes may occur simultaneously. For another, one strike clearly happens first. Neither observer is mistaken. Time is woven together with space into a single fabric called space-time. Our everyday intuition notices only a tiny approximation of this deeper reality. Gravity also turns out to be unlike anything our senses suggest. We often picture gravity as an invisible force pulling objects together. General relativity replaces this image with something far more elegant. Mass bends space-time itself. Planets simply follow the straightest possible paths through that curved geometry. Earth does not orbit the sun because an invisible rope pulls it forward. It travels naturally through a landscape whose shape has been altered by the sun's enormous mass. The distinction may seem subtle, yet it completely transforms our understanding of motion. Even emptiness refuses to remain empty. A perfect vacuum sounds like complete nothingness. Classical intuition imagines absolute silence. Quantum physics reveals constant activity. Tiny fluctuations briefly produce pairs of virtual particles that appear and disappear before they can be directly observed. The vacuum is alive with restless energy. What appears empty is, in reality, one of the most dynamic environments imaginable. Then there is entanglement, one of the most astonishing discoveries in modern science. When two particles become entangled, their properties remain deeply connected even after enormous separation. Measuring one immediately determines correlated properties of the other, according to quantum theory. Einstein famously referred to this as spooky action at a distance, because it challenged deeply held assumptions about locality. Today, countless experiments have confirmed that entanglement is a genuine feature of nature. It does not allow faster than light communication. Yet it demonstrates that reality contains relationships far stranger than classical intuition ever anticipated. Perhaps the most surprising lesson is that mathematics often understands the universe long before human intuition does. Physicists routinely write equations whose consequences seem unbelievable. Years later, experiments confirm them with astonishing accuracy. Black holes were predicted mathematically before they were observed. Gravitational waves appeared in Einstein's equations a century before detectors finally measured them. Antimatter first emerged from elegant mathematics before it was discovered in laboratories. Again and again, nature has shown that beauty within mathematics often points toward truths beyond common sense. Why should this be so? Perhaps because intuition evolved to navigate one narrow environment. Our ancestors never needed to understand neutron stars. They never encountered quantum fields. They never traveled near the speed of light. Their brains became specialists in survival rather than universal comprehension. Expecting intuition to explain fundamental physics may be as unreasonable as expecting a fish to understand mountains. Yet, despite these limitations, humans possess something extraordinary: curiosity. Whenever reality contradicts expectation, curiosity refuses to surrender. Instead of rejecting strange discoveries, scientists ask deeper questions. If experiments disagree with common sense, perhaps common sense is what must change. This willingness to abandon comforting assumptions has transformed civilization. It allowed humanity to leave Earth, decode DNA, harness electricity, and peer billions of light years into the past. Every revolutionary discovery began with someone accepting that intuition could be mistaken. There is quiet humility hidden inside modern physics. It reminds us that reality owes us no obligations to be easily understood. The universe was not designed around human expectations. Its laws existed billions of years before the first conscious observer ever wondered about them. Our task is not to force nature into familiar shapes. Our task is to patiently learn the language in which nature already speaks. Perhaps this is one of the most beautiful aspects of science. It asks us to become comfortable with mystery rather than fearful of it. Every surprising experiment expands not only our knowledge, but also our imagination. The universe becomes stranger, yet somehow even more beautiful. What first appears impossible often becomes tomorrow's ordinary understanding. Children today grow up knowing that Earth orbits the Sun, that galaxies fill the cosmos, and that invisible atoms compose everything around them. Ideas that once seemed absurd eventually become part of everyday education. Perhaps future generations will find quantum reality as natural as we find gravity today. There may still be discoveries ahead that will challenge intuition even more profoundly. New theories may reveal dimensions we have never perceived. They may redefine space, time, matter, or even consciousness itself. If history teaches anything, it is that reality always contains another surprise waiting just beyond the horizon of current understanding. And perhaps that is exactly as it should be. For a universe that perfectly matched our intuition would eventually become predictable. A universe that continually surprises us remains forever worthy of exploration. Its mysteries invite endless curiosity. Its elegance rewards patient observation. Its strange and beautiful laws remind us that understanding is not about making reality simpler. It is about allowing ourselves to grow until we are capable of appreciating how wonderfully extraordinary reality has always been. If these gentle stories make the mysteries of science feel a little closer before sleep, subscribe and continue exploring the cosmos with us on future nights. There are still countless wonders waiting beyond the stars, and together, one quiet evening at a time, we will continue the journey into the infinite. 13. The silence between discoveries. History often appears to move in brilliant flashes. A single observation changes astronomy forever. A single equation reshapes physics. A single experiment opens an entirely new understanding of nature. Looking backward through the centuries, it is tempting to imagine scientific progress as a series of dramatic moments, each one arriving suddenly like lightning across a dark sky. Yet this picture hides something far more profound. Between every celebrated discovery lies an ocean of silence. Years pass, sometimes decades. Occasionally, entire generations spend their lives without witnessing a revolutionary breakthrough. These quiet intervals rarely appear in history books, but they reveal one of the deepest truths about human curiosity. Knowledge does not grow only through moments of revelation. It also grows through patience. Consider the astronomer who spends every clear night recording the positions of stars. Nothing extraordinary happens. The heavens appear almost unchanged. Each observation seems nearly identical to the last. For months, perhaps years, the work feels repetitive. Then one evening, hidden among countless ordinary measurements, a tiny irregularity appears. A planet shifts slightly from its predicted path. A distant star flickers unexpectedly. A faint point of light slowly moves against the background constellations. What appears to the public as a sudden discovery is often the result of thousands of quiet nights that no one remembers. Science is filled with such invisible labor. Johannes Kepler did not discover the laws of planetary motion through a single moment of inspiration. He spent years examining the extraordinarily precise observations collected by Tycho Brahe. Again and again, his calculations failed. Again and again, he began anew. Only after abandoning long-accepted assumptions did the elegant shape of elliptical orbits finally emerge. The breakthrough belonged not only to genius, but also to perseverance. Isaac Newton once remarked that if he had seen farther, it was by standing upon the shoulders of giants. His words remind us that every great discovery rests upon countless smaller efforts that history often overlooks. Behind every famous scientist stand teachers, assistants, instrument makers, observers, and thinkers whose names gradually faded into obscurity. Their work became part of the foundation upon which others could climb. Even Albert Einstein's remarkable insights into relativity did not emerge from complete isolation. They were built upon decades of careful experiments, mathematical developments, and philosophical questions raised by earlier physicists. The silence between discoveries is never truly empty. It is filled with preparation. Sometimes progress requires waiting for technology to catch up with imagination. Einstein predicted gravitational waves in 1916. For nearly 100 years, no instrument on Earth possessed the sensitivity necessary to detect them. Generations of scientists continued refining theories, while engineers designed increasingly sophisticated detectors. Finally, in 2015, the tiny distortions of space-time passed through Earth and were measured directly. The announcement seemed sudden to the world. In reality, it represented a century of collective patience. The universe had been whispering all along. Humanity simply needed to learn how to listen. There are moments when science appears almost motionless. Questions remain unanswered for decades. Researchers publish careful studies that change very little. Progress slows. Some observers begin to wonder whether the greatest discoveries have already been made. History repeatedly proves otherwise. Periods that seem quiet often conceal invisible transformation. New mathematical methods develop. Better telescopes are constructed. More accurate clocks are invented. Computers become faster. Each improvement seems modest on its own. Together, they prepare the next great leap. Nature rarely reveals its deepest secrets all at once. Instead, it rewards persistence. This rhythm resembles the growth of a forest. From a distance, nothing appears to change. Day after day, the landscape looks identical. Yet beneath the soil, roots spread quietly. Tiny shoots strengthen. Cells divide continuously. Years later, towering trees stand where once there seemed to be only stillness. Scientific understanding grows in much the same way. Its roots deepen long before its branches become visible. The human mind often struggles with waiting. We naturally seek immediate answers. Modern life encourages rapid results. Information arrives instantly. Questions can be answered within seconds. Yet the universe moves according to no human schedule. Some mysteries require extraordinary patience. Dark matter has puzzled astronomers for generations. Dark energy remains even more mysterious. The unification of quantum mechanics and gravity continues to challenge the brightest minds. Perhaps these puzzles will be solved tomorrow. Perhaps they will require another century. Either possibility reflects the remarkable complexity of reality. The unanswered questions are not signs of failure. They are invitations to continue exploring. Silence also plays another important role. It gives scientists time to question their own assumptions. When observations refuse to match expectations, the first instinct is often to search for mistakes. Instruments are recalibrated, calculations are repeated, experiments are performed again and again. Only after exhausting every ordinary explanation do researchers begin considering extraordinary possibilities. This careful skepticism protects science from rushing toward false conclusions. Many revolutionary ideas survived precisely because they endured years of intense scrutiny before gaining acceptance. During quiet periods, Theories mature. Weak ideas gradually disappear. Strong ideas become stronger because they survive repeated testing. The silence acts as a filter. Only the most reliable understanding remains. There is beauty in this slow process. It reflects humility before nature. Rather than demanding immediate certainty, science accepts uncertainty as part of learning. Every unanswered question becomes a reminder that the universe remains larger than our current understanding. Perhaps this is one reason scientific discovery inspires such deep wonder. Unlike stories that end neatly, the story of science always leaves another chapter unwritten. Every solution reveals new questions. Every horizon reveals another beyond it. The journey itself becomes more important than any single destination. This perspective changes the way we view history. Instead of celebrating only famous moments, we begin appreciating the countless ordinary days that made those moments possible. A laboratory notebook filled with failed experiments, an engineer adjusting delicate mirrors late into the night, a graduate student checking thousands of observations for tiny patterns, an astronomer patiently waiting beneath cold winter skies. None of these moments appear dramatic. Together, they shape the future. Even failure becomes meaningful. Many experiments produce unexpected results. Some reveal errors. Others simply confirm what scientists already suspected. Yet each contributes a small piece to the larger picture. Science advances not because every attempt succeeds, but because every careful attempt teaches something. The silence between discoveries contains countless lessons that never become headlines. There is another kind of silence as well. It exists within every individual who studies the universe. The quiet hours spent reading difficult equations, the long walks during which ideas slowly take shape, the moments of doubt when every solution seems impossible. Creativity often emerges not amid constant excitement, but during periods of calm reflection. The human brain needs space to connect ideas that at first seem unrelated. Great insights frequently arrive after long seasons of quiet thought. Perhaps the universe itself encourages this rhythm. The stars spend millions of years quietly shining before ending in spectacular explosions. Galaxies evolve over billions of years through gentle gravitational dances. Planets slowly cool. Mountains gradually rise. Even light requires time to cross the immense distances between galaxies. Nature rarely hurries. Its greatest transformations unfold almost imperceptibly. Human understanding follows the same pattern. When viewed across centuries, science appears as a magnificent conversation between curiosity and patience. Questions echo across generations. One scientist begins a puzzle, another continues it decades later. Someone not yet born eventually discovers the missing piece. Knowledge belongs not to individuals alone, but to humanity as a whole. Each generation inherits unfinished questions from those who came before. Each generation leaves new mysteries for those who follow. Perhaps one day future historians will look back upon our own era. They may remember remarkable discoveries we cannot yet imagine, but they will also recognize something we rarely notice while living through it. They will see that today's quiet years were never truly empty. Hidden within laboratories, observatories, universities, and private notebooks, thousands of minds continued asking careful questions. Most answers came slowly. Some have not yet arrived. Yet every observation, every calculation, every thoughtful conversation became another small step toward understanding. The silence between discoveries is not the absence of progress. It is progress unfolding too gently for us to notice in the moment. Like the gradual brightening of dawn, its transformation becomes visible only when we pause and look back. Perhaps that is one of the greatest lessons the history of science offers. The universe does not reveal itself only through spectacular moments of revelation. It also speaks through patience, persistence, and quiet determination. In those long intervals when nothing seems to change, humanity is often learning its most important lessons. The greatest discoveries may begin not with a sudden flash of inspiration, but with someone who quietly continues asking questions long after everyone else has stopped listening. And somewhere tonight, beneath a sky filled with ancient stars, another patient observer may already be taking the first unnoticed step toward the next great chapter in humanity's endless journey to understand the cosmos. 14. Questions without final answers. As science matured through the centuries, an unexpected pattern quietly emerged. The greatest discoveries rarely erased mystery. Instead, every breakthrough seemed to illuminate an even larger landscape of unanswered questions waiting beyond the horizon. Perhaps this is one of the most beautiful paradoxes of human knowledge. We often imagine that learning is like filling an empty container, replacing uncertainty with certainty until eventually nothing remains unknown. Reality appears to work almost the opposite way. Every answer expands the borders of our ignorance. Imagine standing inside a dark cave, carrying only a small lantern. At first, you can barely see the walls around you. As the flame grows brighter, you do not simply reveal more of the cave. You also discover countless new tunnels stretching into darkness that you never knew existed. Greater knowledge creates greater awareness of what still lies hidden. Modern cosmology provides countless examples of this quiet pattern. For much of history, simply understanding that Earth orbited the Sun felt like an extraordinary achievement. Later generations learned that our Sun itself is merely one ordinary star among hundreds of billions inside the Milky Way. Then astronomers discovered that the Milky Way is only one galaxy among hundreds of billions more scattered across the observable universe. Each discovery seemed enormous at the time, yet every larger picture raised questions that no previous generation had even imagined asking. Why do galaxies rotate the way they do? What causes the universe to expand faster instead of slowing down? Why do the laws of physics possess precisely the values that allow stars, planets, chemistry, and eventually life to exist? Instead of shrinking, the unknown kept growing. One of the greatest examples is gravity itself. Isaac Newton described gravity with astonishing mathematical precision. His equations allowed humanity to predict planetary motion, calculate eclipses, and eventually send spacecraft across the solar system. For over 2 centuries, gravity seemed understood. Then Albert Einstein revealed that Newton's explanation was incomplete. Gravity was not truly a force pulling objects together, but the curvature of space and time themselves. This new picture solved problems that Newton's equations could not explain. Yet Einstein's masterpiece introduced entirely new mysteries. Why does gravity resist unification with quantum mechanics? What happens inside black holes where Einstein's equations seem to fail? Can space-time itself emerge from something even more fundamental? The answer became another doorway. Quantum mechanics tells a similar story. Scientists developed its mathematical framework with astonishing success. Today, nearly every modern technology depends upon it. Computers, lasers, MRI scanners, semiconductors, and countless medical instruments all rely upon quantum theory, working with extraordinary accuracy. Yet, almost nobody agrees on what quantum mechanics actually means. Does reality remain undefined until observation? Do countless parallel universes branch from every quantum event? Does some deeper hidden structure exist beneath quantum uncertainty? The mathematics predicts experiments with incredible precision. The interpretation remains surprisingly open. It is as though humanity has learned to read an unfamiliar language perfectly, while still wondering what the language ultimately describes. Then there is consciousness. Neuroscience has mapped remarkable portions of the human brain. Researchers understand many electrical pathways, neurotransmitters, memory systems, and sensory networks. Yet one profound question quietly remains. Why should physical processes produce subjective experience at all? Why does the firing of neurons become the feeling of warmth, sadness, color, music, or love? Some philosophers call this the hard problem of consciousness because explaining brain activity may never fully explain experience itself. Perhaps future generations will solve it? Or perhaps entirely new questions will appear the moment they do. Even mathematics, often considered the realm of certainty, contains mysteries that refuse simple resolution. Kurt Gödel demonstrated that within any sufficiently powerful mathematical system, there exist true statements that cannot be proven from the system's own rules. This astonishing result suggests that even pure logic possesses natural limits. No matter how complete a system appears, some truths always remain beyond its reach. The universe itself may reflect a similar principle. There may always be questions that cannot be answered from within the universe using only the tools available to observers living inside it. This possibility feels strangely humbling. Imagine characters living inside an immensely complex novel. They might spend centuries discovering the rules governing their world. They could map every city, measure every mountain, and understand every season. Yet, they might never discover the author because the author exists outside the framework of the story itself. Whether our own universe contains such limits remains unknown. Another enduring mystery concerns the beginning of everything. Modern cosmology describes the universe expanding from an incredibly hot, dense early state nearly 13.8 billion years ago. But what happened before? Some physicists argue that the question itself has no meaning because time may have begun with the Big Bang. Others suggest that our universe emerged from a previous cosmic cycle. Still others imagine quantum fluctuations, giving birth to entire universes within an endless multiverse. Each proposal is mathematically fascinating. None has yet achieved definitive confirmation. The deeper researchers investigate the beginning, the more the beginning seems to recede beyond reach. Dark matter presents another remarkable example. Astronomers observe its gravitational influence everywhere. Galaxies rotate too rapidly. Galaxy clusters remain bound together. Light bends around invisible mass. All evidence points toward something real. Yet, after decades of searching, no laboratory has directly identified the particles responsible. The universe appears to contain vast amounts of matter that no human has ever actually seen. Dark energy is perhaps even more mysterious. Observations suggest that roughly 70% of the universe consists of something driving cosmic expansion ever faster. Its nature remains almost completely unknown. Scientists have given it a name. Naming something, however, is not the same as understanding it. Sometimes scientific language serves as a placeholder for ignorance rather than its elimination. History reminds us that this has happened before. People once spoke confidently of phlogiston to explain combustion. Later generations replaced it with oxygen chemistry. Perhaps one day dark energy will seem equally obvious, or perhaps it will reveal something even stranger than we currently imagine. This continual unfolding of mystery is not a weakness of science. It is one of its greatest strengths. Science does not promise final certainty. Instead, it offers an endlessly improving conversation with reality. Every experiment asks nature a question. Nature answers only the question that was asked. Then humanity must learn how to ask better ones. Perhaps this is why genuine scientists often become more humble as their knowledge grows. The beginner sometimes believes every mystery is close to resolution. The expert sees how vast the unknown truly is. Astronomer Carl Sagan once compared science to standing on the shore of a great cosmic ocean. Generation after generation walks a little farther into the water. The horizon never becomes smaller. It simply moves with us. Maybe this is exactly how understanding is meant to work. The universe does not seem to be a puzzle with one final piece waiting to be placed. It resembles an infinite landscape, where every mountain climbed reveals another range beyond it, stretching farther into silent distance. And perhaps that is not something to fear before sleep. Perhaps it is something quietly comforting. If every mystery could someday disappear, wonder itself might vanish with it. Instead, tomorrow will always contain questions no human has yet imagined. Somewhere tonight, beneath the same stars that inspired our earliest ancestors, a child may look upward and ask a question that will shape the science of centuries still to come. The universe has never stopped inviting us to ask. It simply never promised that every answer would be the last. 15. Beyond the horizon of knowledge. Perhaps the greatest mystery is not hidden somewhere beyond the edge of the observable universe. Perhaps it exists much closer, quietly woven into the limits of our own minds. Every generation has believed, at least for a time, that it was approaching a complete picture of reality. The confidence is understandable. With every breakthrough, another piece of the puzzle falls into place. The motions of planets become predictable. Invisible atoms become measurable. Galaxies, once imagined as isolated islands, become members of an immense cosmic web, stretching farther than anyone had dreamed. Each discovery expands the map. Yet every expansion also reveals that the unexplored territory has grown even larger. The horizon never disappears. It simply moves farther away. This curious pattern has repeated throughout history with remarkable consistency. Scientists solve one question only to uncover 10 new ones hiding beneath it. Answers behave less like endings and more like doorways opening into even deeper rooms. It raises an unsettling possibility. What if knowledge has no final destination? Imagine standing on a beach at sunrise. In the dim morning light, the shoreline seems short and familiar. As the sun climbs higher, more coastline becomes visible. You have learned more about the beach than you knew before, but notice something unexpected. The amount of ocean touching the shore has also increased. Knowledge works in much the same way. The larger our island of understanding becomes, the longer its coastline of mystery grows. This idea has comforted many scientists rather than discouraged them. They have learned that mystery is not evidence of failure. Mystery is evidence that exploration remains alive. Still, there may exist questions forever beyond our reach, not because they lack answers, because our minds may simply be unable to formulate them. This possibility feels strange because humans naturally assume intelligence is universal. We often imagine that with enough time, patience, and technology, every puzzle can eventually be solved. History encourages optimism, but nature does not necessarily guarantee it. Consider other creatures sharing our planet. A dog can navigate a world of scents so rich that humans can barely imagine it. Bees perceive ultraviolet patterns painted across flowers that our eyes cannot detect without instruments. Bats construct detailed maps using echoes instead of light. Each species experiences reality differently. Their brains evolved to solve specific problems. Not every aspect of existence becomes available to every kind of mind. Now imagine trying to explain quantum mechanics to a squirrel. No matter how patiently you speak, the squirrel lacks the conceptual framework required to understand wave functions, uncertainty, or probability amplitudes. Its brain evolved for finding food, avoiding predators, and navigating trees. The limitation is not caused by laziness. It is built into the architecture of cognition itself. Could humanity occupy a similar position? Could there exist layers of reality that remain permanently inaccessible because our brains evolved for survival on African savannas rather than for comprehending the deepest structure of space-time? It is a humbling thought. Our ancestors needed to recognize faces, estimate distances, predict seasons, and cooperate with one another. Natural selection rewarded practical intelligence, not cosmic understanding. The mathematics we use today required thousands of years of cultural development. Without symbols, language, and accumulated knowledge passed from one generation to another, much of modern science would never have emerged. Our intelligence is remarkable, but it also carries fingerprints of its evolutionary history. Perhaps there are ideas that no amount of education can reveal because they require entirely different kinds of minds. Some philosophers compare this to color vision. Imagine someone born without the ability to perceive blue. Every description would fail. They could memorize equations about wavelengths and light, yet the actual experience of blue would remain forever absent. Maybe certain features of the universe are like unseen colors. They exist. But human consciousness lacks the necessary receptors. Physics itself occasionally hints at these boundaries. Modern theories describe dimensions beyond the familiar three dimensions of space. Some mathematical frameworks suggest realities that cannot be directly visualized because human intuition evolved entirely within ordinary spatial experience. We manipulate equations successfully, yet imagining them often proves impossible. Our mathematics can travel farther than our imagination. This gap may become increasingly important as science advances. Artificial intelligence introduces another fascinating possibility. Machines are beginning to identify patterns in enormous data sets that humans struggle to recognize. Some discoveries emerge not because researchers fully understand every intermediate step, but because algorithms reveal relationships hidden within overwhelming complexity. If future intelligences become vastly more capable than humans, they might uncover truths that we ourselves cannot intuitively grasp. Would we still consider those discoveries to be knowledge if we could not fully understand them? Or would they resemble mysterious instructions received from an intelligence beyond our own? The question echoes an ancient paradox. What does it mean to know something? Is it enough to predict outcomes? Or must understanding include deep conceptual insight? Science has always balanced between these two goals. Sometimes equations work perfectly long before anyone truly understands why. Even today, quantum mechanics produces astonishingly accurate predictions while continuing to challenge our deepest intuitions about reality. Perhaps explanation itself has limits. Perhaps certain truths resist translation into concepts that human language can comfortably express. This possibility does not diminish science. Instead, it highlights the extraordinary achievement already represented by what humanity has learned. For a species living briefly on a small rocky planet orbiting an ordinary star, our understanding has reached astonishing distances. We have reconstructed the history of galaxies billions of light years away. We have measured ripples in space-time itself. We have detected planets orbiting distant suns. We have estimated the age of the universe. Each accomplishment would have appeared indistinguishable from magic to our distant ancestors. And yet every triumph quietly reminds us how much remains unknown. Dark matter continues to hide its identity. Dark energy continues to accelerate cosmic expansion without revealing its true nature. The origin of consciousness remains deeply mysterious. The reconciliation between quantum theory and gravity remains incomplete. The beginning of time itself remains uncertain. Every frontier opens into another. Perhaps this endless progression is not a flaw, but the defining characteristic of reality. The universe may not resemble a book with a final chapter waiting to be read. It may resemble an infinite library where every completed volume reveals countless unopened shelves beyond it. That image carries an unexpected kind of peace. If complete knowledge is impossible, then curiosity never becomes obsolete. There is always another sunrise to observe, another equation to test, another telescope to build, another quiet question waiting in the darkness. Even civilizations far older than ours, if they exist, may share the same experience. Perhaps they too continue asking questions, with no final answers. Perhaps they also gaze toward horizons that retreat as they approach. The universe may remain infinitely generous in offering mysteries to every intelligence capable of wondering. And maybe that is exactly as it should be. A universe that could be fully explained might eventually become predictable, familiar, and silent. Instead, ours continues whispering invitations. Look closer. Think deeper. Question again. Those whispers have carried humanity from stone tools to spacecraft, from myths beneath the stars to observatories orbiting above Earth's atmosphere. They have inspired generations separated by centuries, yet united by the same quiet instinct to ask why. Perhaps that instinct itself is one of the universe's greatest creations, not certainty, not complete understanding, but the endless desire to seek both. As the night sky slowly turns overhead, every distant star reminds us that the boundary between knowledge and mystery has never been fixed. It shifts with every discovery, always inviting us one step farther. We may never reach the ultimate horizon of understanding, but perhaps the journey itself is the true destination. In continuing to ask questions that stretch beyond today's answers, humanity participates in something far larger than any single lifetime, a conversation with the cosmos that may never truly end, and whose greatest beauty lies precisely in the fact that there is always one more question waiting beyond the light. 16. The universe that never truly ends. Imagine standing at the edge of an endless ocean just before dawn. The horizon stretches so far that the sea and sky seem to dissolve into one another. You know that somewhere beyond that line are distant shores, unseen islands, perhaps entire continents. Yet, no matter how far any ship sails, the horizon never disappears. It simply moves farther away. Knowledge behaves in much the same way. Every generation has believed, at least for a moment, that it was approaching a complete understanding of reality. Every generation has eventually discovered that what looked like the finish line was only the beginning of another journey. The ancient astronomers believed the heavens were nearly understood once they mapped the wandering planets. Then the telescope revealed countless new worlds beyond naked vision. The physicists of the 19th century believed that nature had nearly surrendered all her secrets. Then relativity transformed space and time, while quantum mechanics reshaped the smallest building blocks of existence. Even today, after centuries of astonishing discoveries, we find ourselves surrounded by mysteries that seem larger than ever. We know that ordinary matter, the stars, planet, dust, and every living creature, makes up only a tiny fraction of the universe. The vast majority consists of dark matter and dark energy, invisible components whose true nature remains uncertain. It is a remarkable thought. Everything humanity has ever built, every mountain climbed, every ocean crossed, every civilization that has risen and fallen, every poem, every dream, every question ever asked, all exist within a small portion of reality that we actually understand. The rest waits patiently in silence. Perhaps that silence is not empty. Perhaps it is simply speaking a language we have not yet learned. There is a comforting humility in this realization. It reminds us that the universe does not exist to satisfy our curiosity. It simply exists. It unfolds according to laws that may extend far beyond the reach of human imagination. Our minds evolved to survive beneath African skies, to recognize faces, predict seasons, and find food. Yet somehow those same minds learned mathematics, built observatories, detected gravitational waves, and photographed black holes. This extraordinary journey suggests something beautiful. Intelligence is capable of growing far beyond the environment that created it. Still, every tool we invent reveals new limitations. The larger our telescopes become, the farther they can see into space. But looking farther into space also means looking farther back in time. Eventually, we reach the earliest light after the birth of the universe. Beyond that lies a boundary, not because nothing exists beyond it, but because light itself cannot yet tell us the story. Our instruments encounter horizons. Our theories encounter horizons. Even our language encounters horizons. Some concepts in modern cosmology stretch so far beyond ordinary experience that everyday words become inadequate. We borrow metaphors from waves, fabrics, particles, dimensions, and landscapes, knowing that none of them fully capture reality. The universe continually reminds us that description is not the same as understanding. Sometimes the greatest progress begins by admitting that we do not yet possess the right questions. History offers many examples. Before gravity was understood, asking why apples fall toward Earth was already a remarkable question. Before electricity was explored, few imagined that invisible forces could illuminate entire cities. Before DNA was discovered, no one knew to ask how microscopic molecules could store instructions for life itself. Each breakthrough depended upon discovering not only better answers, but better questions. This pattern may continue forever. Perhaps future civilizations will ask questions that sound as strange to us as quantum mechanics would have sounded to philosophers 2,000 years ago. Perhaps they will see dimensions we cannot imagine. Perhaps they will manipulate space and time as naturally as we now manipulate electricity. Or perhaps they too will encounter mysteries that refuse to yield completely. There may always remain another horizon. In that sense, infinity is not merely a property of the cosmos. It is also a property of learning. Every solved puzzle creates new puzzles. Every explanation uncovers deeper layers. Every map reveals unexplored territory beyond its edges. Far from being disappointing, this endless expansion gives science its quiet beauty. A universe with no remaining mysteries would eventually become silent. Curiosity would fade. Discovery would end. Wonder would become unnecessary. Instead, the cosmos offers an inexhaustible invitation. There is always another star to observe, another equation to test, another fossil to uncover, another signal to decode, another mystery waiting patiently beneath the surface of what we believe we already know. Perhaps this is why people continue looking upward. Across thousands of years, children and philosophers have shared the same instinct. They step outside on clear nights, lift their eyes toward the stars, and experience the same quiet feeling that words struggle to describe. It is a mixture of awe and belonging. We recognize that we are unimaginably small, yet we also recognize that the atoms within us were forged inside ancient stars. The universe is not something entirely separate from ourselves. It is our oldest ancestor. The calcium in our bones, the oxygen in our lungs, the iron flowing through our blood, all began inside stellar furnaces billions of years before Earth existed. In a very real sense, the cosmos has spent billions of years slowly learning to observe itself through conscious beings. That realization transforms the search for knowledge into something deeply personal. When humanity studies the universe is, in a way, reflecting upon its own history. Perhaps that is why our questions never truly end. They are woven into the very process that produced us. Each generation inherits unanswered mysteries from those who came before. Each generation solves a few while creating many more. This is not failure. It is the rhythm of understanding itself. Like waves reaching a shoreline, knowledge advances gradually, retreating only to gather strength before moving forward again. The horizon remains distant, not because we are lost, but because reality is richer than any single lifetime could ever contain. And maybe that is exactly as it should be. If every secret were revealed tomorrow, the adventure would be over. Instead, tomorrow brings another sunrise, another observation, another unexpected result. Another young mind asking a question that no one has ever asked before. Somewhere, perhaps tonight, a child gazes at the stars and wonders about something that will one day reshape everything humanity believes about the universe. The story is still being written. We are only one chapter within it. Long after we are gone, future explorers will continue walking toward horizons that forever retreat into the infinite distance, carrying with them the same quiet curiosity that has guided our species since the first humans looked into the night sky. Thank you for spending this peaceful journey through cosmic time with us. If these quiet stories help you relax, wonder, or simply drift beneath the stars, don't forget to subscribe. Until our next voyage, sleep well, and may the universe keep whispering its mysteries through your dreams.